Welcome to section 2.3, formulas and problem solving. Let's get some rearranging going on. We solve A for S. So what that means is we have to rearrange this equation. We want to solve for S. We want to make sure that S gets all by itself. This guy right here, S. Everything else has to go to the other side. Well, we have to undo the subtraction first. So we subtract, hold on, that's not the right color. Subtract pi r squared. Subtract pi r squared from both sides. We get a minus pi r squared. Again, we're just rearranging this equation so that s is all by itself. Then we need to undo this multiplication with division. Divide both sides by pi r, divide both sides by pi r. We get a minus pi r squared all over pi r. And that is equal to s. We've solved it. Another one bites the dust. Here we go. Solve this. Wow, that's a lot of fractions. This formula is actually incredibly useful for SAT problems and also for circuits. So I hope we get to use this a couple of times. The very last thing that I'm going to do is I'm going to take the reciprocal of both sides, and that would, it'll be like 1 over r is equal to a whole mess, and then the last step is I'm going to take the reciprocal of both sides, and we get r is equal to 1 over the entire mess, right? So in order to do that, I have to first combine these two fractions together. And so I'm going to have 1 over r is equal to, well, we need to get a least common denominator, don't we? I think that least common denominator could only be r1 times r2. r1 times r2. And so what do we have to multiply the first fraction by to get that least common denominator? We need to multiply both the top and the bottom by r2. So therefore we get r2 plus, same thing over here, r1. Multiply both by r1, we get this, r1. Great, so now that we have common denominators, we can add them together. We get r2 plus r1 over r1 times r2. Now that we have just one fraction, we can take the reciprocal of both sides, and we get r is equal to r1 times r2 all over r1 plus r2. That's actually a big hairy deal because this equation gets used a lot in electrical circuits, which you might not be an electrical engineer, but you will take the SATs and you will be using this for work problems. In fact, you'll see later today. Bam, distance, rate, time. I love distance equals rate times time. Example 8, a boat travels 246 kilometers downstream at the same time that it takes to travel 100 kilometers upstream. The speed of the current in the stream is 5.5 kilometers per hour. So this stream is traveling, and so is the boat. And sometimes it's fighting the current, sometimes it's being assisted by the current. The strategy we have for these kinds of word problems, or any kind of word problems, is really to make sure you track down your knowns and unknowns. So my knowns are, which going upstream is 180 kilometers, and going downstream is 246 kilometers. Those things are known. What we don't know is the speed of the boat in still water. Like, how fast can this boat really travel? I'm going to call that r. So that means that the speed going upstream, it's going to be slowed down by the current when it goes upstream. So therefore, it's going to be slowed down by the 5.5 that was mentioned. Your speed is r minus 5.5 kilometers an hour. It's the speed of the boat in still water and then slowed down by the current because it's trying to go upstream. Then we can do the exact opposite and saying going downstream it's going to be 5.5 kilometers per hour assisted. It's going to be going faster than it would be in still water. And we don't know what the time is, but we can say that it's the same variable. It's the same time going upstream and downstream. That way we can use just one variable. Now, because distance equals rate times time, or distance equals speed times time, we can actually turn these into equations. we can say that 180 kilometers is equal to r minus 5.5 times t, and 246 is equal to r plus 5.5 times t. Now, the one variable that we can isolate is t. We can solve both of these for t. We get 180 over r minus 5.5 is equal to t, and 246 over r plus 5.5 is equal to t. Since we have two things that are both equal to t, let's set them equal to each other. We get 180. I know it's an ugly fraction, but it's going to work for us. It's a fraction that has a decimal? Wow. 246 over r plus 5.5. And now we can cross multiply. 180 times r plus 5.5 is going to equal to 246 times r minus 5.5. Again, cross multiplying looks like this. When you cross multiply, you multiply a times 5 to get 5a, and 2 times 3 to get 6. On the other side, 2 times 3 is 6. So that's cross multiplying. We're doing the same thing here, multiplying r plus 5 times 180 and r minus 5 times 246 right here. And after doing a whole lot of distributing and subtraction, combining like terms, and then solving the equation, you eventually get the rate, the speed in still water is going to be 35.5 kilometers per hour. Interest. So the great thing about interest is that if you give people your money to hold, then they will pay you for it. And that's a huge principle that carries all throughout the financial world. If people want to give you, if you're the person who is receiving money in a loan, then they're gonna charge you interest. So you're gonna pay for it. However, if you have some extra money lying around and you want to invest it into a mutual fund or a bank or whatever, the idea is that when you let people hold your money, that they will pay you for it. And how much? Well, that's how much we calculate it using an equation. So what do these variables mean? A, P, I, T? Well, A is the final amount, like the total amount that you get at the end of this whole deal. And then P is your starting amount. P is called the principal. I is the interest rate, which is usually, in the equation you need it as a decimal. And then T is the time, and that's usually measured in years. In this formula, it's very similar, except you also have the n, and the n is going to be how many times a year. So the real question is, are they going to pay you that interest every year, or every 6 months, or every 3 months, or every month, every week? How often are they going to give you interest? And if it's just going to give you interest once a year, they say it's compounded annually. So we're going to use this equation right here. An investment is made at 8% compounded annually. It grows to $1,404 at the end of 1 year. How much was originally invested? So the knowns that we have, the knowns are that the interest rate is equal to 8%, which we can even turn into a decimal right away. The time, it says 1 year. 1 year. The 1404, that's going to be the final amount, A, $1,404. And what is unknown, we want to find the P, the principal amount, how much it was originally invested. Using the equation, we can substitute, and we get A equals P times 1 plus I to the T power. So, substituting our knowns, we get 1404 is equal to the unknown P times 1 plus 0.08, all raised to the first power. And when we do the math and we simplify this, you're dividing both sides by 1404 is equal to P times 1.08, divide both sides by 1.08. And we get the principal is equal to $1,300. Notice that my answer has units. Very important. So let's say they weren't just going to give you interest at the end of every year. Let's say they're going to give it to you quarterly. Now remember that n is going to be the times per year. So quarterly means every 4 times a year. The knowns are going to be that n is equal to 4 times a year. The 1,000 is the principal amount. The interest rate, is going to be 0.09, that's 9%, and t is going to be 10 years. And what's the unknown? What's the thing we're trying to find? It's how much money. Show me the money, people. How much money is going to be in your bank account? That's A. Substituting everything in, we get A is equal to, well, let's not substitute yet. Let's write out the formula. Getting ahead of yourself. Slow down, Bergman. NT. Writing out the formula so it helps me memorize. We get A is equal to 1,000 times 1 plus 0.09 over 4 raised to the 4 times 10, 40. If you plug all that into a calculator, $2,435.19. The book actually spends a long time developing these formulas and showing you where they come from. And I'd love to do that too, but except it would make for a super long video, so I'm not going to do that. But if you want to know where these formulas come from, check out the book, or we can talk about it in class too. Next, the radius of a circular swimming pool is 10 feet. A sidewalk of uniform width is constructed around the outside and has an area of, 44 pi feet squared. How wide is the sidewalk? So I'm going to draw a little picture here. It's going to be kind of like a donut with a pool on the inside, and the actual donut, a ring around the outside, is going to be the sidewalk. And you can see that the two things that they tell us is that the pool has a radius of 10 feet. I've drawn that in. And then it's the sidewalk of uniform width is constructed around the outside. That's kind of like the outside of the part of the donut. And it's the actual ring. And then it has an area of 44 pi feet squared. Wants to know how wide is the sidewalk. The one thing that we don't know, so we know those two facts, and I've listed them as knowns. The radius of the swimming pool equals 10 feet, and the area of the swimming pool, the area of the sidewalk is 44 pi feet squared. The one thing we don't know, and it's, if you know where to look for this, it's always in the question. How wide is the sidewalk? The question will give you the unknown. Right here. The width of the sidewalk, and we're going to call it x. Once we do that, then we can start to write an equation. And it looks like this. The area of the total area minus the area of the pool, of the swimming pool, is going to equal the area of the sidewalk. You take the total donut area, the circular area, and subtract out the donut hole, you're left with the area of the donut itself. So then we can start filling things in. The area of the sidewalk, we know that's 44 pi. We don't exactly know the area of the swimming pool, but we know its radius. That would be pi radius squared. And then the total area, well, we don't know it either, but we can find its radius. The total radius is going to be 10 plus x. That's going to be pi times 10 plus x squared, pi r squared. To draw it in the picture, it would look like this. if the inner radius is 10 and the outward extension is x, then the total radius is going to be 10 plus x. So now, here we have an equation, and the only unknown is x. First thing I want to do is divide all the terms on both sides by pi. I think that'll just simplify everything to get that pi out of here. The quantity 10 plus x squared minus 10 squared equals 44. We do a little squaring, a little foiling, and we get 100 plus 20x plus x squared minus 100 is equal to 44. Combining like terms and rearranging things a little bit, we get x squared plus 20x minus 44 equals 0. And so then you have to ask yourself, what two numbers multiply up to negative 4 and add up to 20? That would be positive 22 and negative 2. So you can rewrite the equation as x plus 22 times x minus 2 is equal to 0. Splitting the equation up, you get x plus 22 is equal to 0, or x minus 2 is equal to 0. So therefore x, the width of the sidewalk, can be either a negative 22 feet, or x could equal positive 2 feet. And of course, width of a sidewalk can't be negative, so therefore the answer is x equals 2 feet. Problems regarding time to do work. So here's the same kind of formula that we saw at the very beginning. Before it was with R's, and that was to represent resistances in electrical work. The resistance of a resistor. If you had two resistors that were kind of working together, how much would the total resistance be? Well, it's the same structure here. Typist A can do a certain job in 3 hours. Typist B can do the same job in 5 hours. How long would it take it both working together to do the same job? If both typists are kind of combining their efforts together, then how do you structure that? How do you calculate the length of time it would take them to do the same job? You would estimate, as an estimate, you would have to be definitely less than 3 hours, maybe around 1 or 2 hours, right? If they're doing the same job, if they're both typing the same job together, then it would take them less time than either of them together, than 3 or 5. The knowns are that time for typist A would be 3 hours, and the time for typist B would be 5 hours for the same job. The unknown would be the total time. And I don't know if you remember from the beginning of notes, but when we rearranged this, when we solved for R, we found out that R was equal to R1 times R2 over R1 plus R2. We're going to do the same thing here. We're going to say that this formula can be recombined in the same way. 1 over the total time is going to equal 1 plus time A plus 1 over time B. Dot, 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 dot. If you know the structure, then you can just say that the total time is going to equal time A times time B over time A plus time B. 3 and 5 hours. The total time is going to equal 3 hours times 5 hours over 3 hours plus 5 hours. Total time is going to equal 15 over 8 hours. Or, as a decimal, that's going to equal 1.875 hours. Now, if you wanted to, you could plug in the numbers directly at the very beginning. You could say 1 over the total time is going to equal 1/3 plus 1/8, 1/5, and you would get 1 over t is equal to 8/15, and so therefore the time is going to equal 15 over 8 hours, which is the same thing we get here. I think it's actually handy to have this formula memorized for the SATs, because this is often the kind of problem that they give you. It takes Matt 9 hours longer to build a wall than it takes Chris. If they work together, they can build the wall in 20 hours. How long would it take each working alone to build the wall? So let's write down our knowns and unknowns. Knowns. Unknowns. It takes Matt, the time from Matt is going to equal 9 plus Chris. The time for total is 20 hours. What we don't know is time for Matt or time for Chris. Well, if we knew the time for Chris, then we could say we would figure out what the time for Matt is. So what we really want is the time for Chris. Let's use the formula. The one we have memorized is going to be T total is going to be time for Matt times time for Chris all over time for Matt plus time for Chris. That's going to be 20 hours is equal to 9 plus TC times TC over 9 plus TC plus TC. I'm going to multiply both sides by, this is a C by the way, by this denominator to bring it over to the other side. And so we get 20, 9 plus TC plus TC equal to, and I'm going to distribute 9TC plus TC squared. Distributing over here, we get 180 plus 20 TC. I'll make that 40. Because you can combine the two TCs together, and then when you distribute, you get 180 plus 4 TC is equal to 9 TC plus TC squared. Let's bring it all over to one side. We get 0 is equal to TC squared minus 31 TC minus 180. And so then you have to ask yourself what two numbers times themselves get negative 180 and add up to negative 31. And that would have to be negative 36 and positive 5. And so we can rewrite this as TC plus 5 times TC minus 36. And so then splitting up the equation, we get TC plus 5 is equal to 0, or TC minus 36 is equal to 0. So the time that it takes Chris would have to be TC equals negative 5 hours, or the time that it would take Chris would have to be positive 36 hours. And that's the case up here, so time for Chris is 36, and then time from that would be 9 hours later. Done. Alright, good people, I just want to let you know that Sydney is the capital of Australia. That's your audio check, and I hope you enjoy yourselves. If you've ever been to Australia, then let me know, because I would really love to go to Australia. Sydney's the capital. Have a fun time, and I will see you in class. And by the way, I forgot to mention, now's a good time for you to begin 2C. I really need you to write the heading inside your composition book and begin the first problem. Thanks very much, and I will see you in class.